We've now stopped our study of ionic compounds because we've gone through all the key points that you need to learn. What I'd like to do in this video is take you in a slightly different direction to look at another family of compounds aside from ionics, and these are called molecular compounds. To introduce you to molecular compounds, I'd like to just go over sort of what our original definition of ionic compounds has been. And looking from a periodic table standpoint, ionic compounds have been traditionally, up till now, looking at something that's located on the left-hand side, giving up electrons, to something that is located on the right-hand side of the staircase over here. Or we've also looked at it in terms of these things on the left-hand side are called metal elements. So we could have a metal gives up electrons and bonds with something on the right called a non-metal. There we go. Okay, and that's been sort of our traditional definition up to this point. However, molecular compounds have a completely different take on things, and instead they are about looking at these nonmetals over here on the right-hand side of the staircase and how they can combine to form compounds. So molecular compounds are nonmetals bonding with nonmetals. And so you can see I've highlighted two key elements on that side of the periodic table. We have a carbon and an oxygen. And I've got two compounds listed at the bottom of the screen here that are familiar to us. We have CO, which is one carbon to one oxygen, and carbon with two oxygens, or CO2. Now, using the rules that we've learned up until now, something doesn't quite work here. How in the world can CO exist if carbon, being in group number 4 here, having its 4 valence electrons, tries to, you know, bond ionically with something in group 6? And here the other fact is that both of these things like to gain electrons according to the fact that they're both nonmetals. So which one's going to give up if they both want to gain? And again, from a charge standpoint, this thing can be a 4 plus or 4 minus, and this can be a 2 negative, so this theory just goes completely out the window. So what we're going to do is we're going to look at the bonding inside of there in class. And today all we want to do is get familiar with the chemical formulas and the IUPAC names for these molecular compounds. And molecular compounds have a different type of bonding, just to give you a preview, called covalent bonding, in which electrons are shared between nonmetals rather than one losing and one taking. Whereas up here, we have ionic bonding, cation and anion. Okay, so in order to name this compound, what we're going to do is the same process we've done with ionic compounds. We're going to identify what the first element is, and here it is, carbon. And then we're going to identify what the second element is, and we know it's oxygen. But in our ionic rules, we've always changed the name of the second listed thing when it's been a nonmetal to having an IDE ending, so we're going to call this carbon oxide. But the problem here is that because we don't have valences to know that these are in fact combined in a 1-to-1 ratio, it would be much more nice if we could actually indicate in the name that there's one of each of them there. And so we could call this monocarbon monoxide. The interesting thing about this prefix mono, though, is it seems in the IUPAC world to only be reserved for being used with the element that is listed second. And so if you don't see a prefix out in front here, it's meant to be a 1, and I guess they've deemed that saying monocarbon monoxide is redundant, and so they've just left the mono out of that first part of the name. If we look at sort of a similar scenario over here with this molecule CO2 and we try to name it, we can name this first part carbon. And as I said before, we don't have to call it monocarbon because we can leave the mono out for the first element that's listed in these small molecular compounds. But over here, we would call this oxide. And of course, we can't have the name carbon oxide for two compounds that contain carbon and oxygen because one name isn't going to work when they have different proportions of elements in them. So over here, we had used the prefix mono to indicate that there was one oxygen. I wonder what prefix we could use over here. Well, you guys are familiar with, I'm sure, that this molecule is in fact called carbon dioxide. And so the prefix di here is used to indicate that there are two oxygens in that particular compound. Now, in case you haven't noticed already, these prefixes, mono and di, are familiar prefixes. We used them in a previous video in front of the number of waters that might be present in an ionic compound too. And so they aren't new prefixes for you. We just have to refresh ourselves with them. So let's take a look at, again, just the basics here, molecular compounds of going from the chemical formula to the name and from the name to the chemical formula. So up here at the top, I see N2O5. Both nitrogen and oxygen are nonmetals on the periodic table, and so right away I know that this is a molecular compound just by inspection. So I want to name it, and I recognize there are two pieces I have to account for in the name, the piece here and the piece here. So the first piece is going to be called simply nitrogen, and the second piece is oxygen, but we have to change it to oxide with this IDE ending. Now, we can't use valences to show that they're in a 2:5 ratio, so instead we're going to simply use prefixes. So the prefix for 2, as we saw in the previous slide, is di. We can call this dinitrogen. And the prefix for 5, you may recall back in our hydrate study, is penta. So this would be dinitrogen pentoxide. And you can decide if you want to leave the penta in or the letter A out and just call it pentoxide. I've seen textbooks that do both. I like pentoxide personally, but I will accept both answers regardless of which way you go with it. So dinitrogen pentaoxide or pentoxide would be sufficient as well. No valences to worry about, just using prefixes to show the proportions or the ratios of nitrogens to oxygen. So these compounds are easy peasy to work with because there's nothing fancy. So let's go the other way. If we are given the name of a molecular compound, here we have diphosphorus tetraoxide, let's break it down into its component pieces that we need in order to come up with its chemical formula. So diphosphorus. Phosphorus's chemical formula on the periodic table is P, and the di prefix tells me that there are two of these in the chemical formula. So I'm going to write P2 here. Tetraoxide, I know that the symbol for oxygen is O, and the fact that there are 4 of them, according to that prefix tetra, means that I write a chemical formula of P2O4. So again, easy peasy, use prefix system. Don't worry about valences anymore to come up with chemical formulas or names. Just write down what you see.